In this section, we are going to review simplifying radical expressions. We are going to be working out of section 7.2 on page 573, and we are going to work numbers 2 through 46 even. On number 2, we have the square root of 24. To simplify this radical expression, we are going to make what's called a prime factorization tree by breaking this 24 up to be numbers that multiply to give you 24 and break them down until you have nothing but prime numbers left. So I'm going to choose the numbers 6 and 4. You could have used the numbers 2 and 12. You could use the numbers 3 and 8. Either one of these would work. If you would like to try using those factors, you're more than welcome to. You will notice you will come up with the same answer that I do. Then I'm going to break the 6 down to be a 2 and a 3 because 2 times 3 gives me 6. Every time I have a number that is prime, meaning it only has factors of 1 in itself, I'm going to circle it. The 4 will break down to be a 2 times 2. Those are prime numbers, so I'm going to circle them as well. Now, I'm going to replace my 24 with my prime circled numbers. Again, once you have nothing but prime numbers at the end of your tree, and they're all circled, you are finished. So now we are going to want to put these 4 numbers under the radical to replace the 24, and we want to group them where all the 2's are grouped together and the 3 is at the end. You may remember in lesson from 7.1 where this number here is called the index, and it tells you how many you need of a number to release it from the radical, or what number times itself gives you that number. So if it is not written as it was not in this problem, then we are understood that it is a 2. So we need 2 of a number to release it from the radical. So I'm going to circle this pair of 2's. So this pair of 2's is going to come out as 1, 2, and then I have that 2 times 3 left over. To finish simplifying this problem, I'm going to multiply 2 times 3 to give me 6. Now I'm finished with simplifying this radical expression. Number 4, we have the square root of 28. So 28 could be broken down to be 2 times 14. I'm going to circle the 2 because it is a prime number. Then I'm going to break down the 14 to be 2 times 7. They are both prime numbers, so I'm going to circle them both. And I'm going to replace this 28 with my 2's and my 7. I need 2 of a number to bring it out. That's what that invisible index means. So the 2's come out as just 1, 2, and then I have the 7 still under the radical. The way you can remember that the 2's just come out as 1 is that 2 times 2 gives you 4, and the square root of 4 is 2. Same thing from number 2. This 2 times 2 gives me 4. The square root of that 4 would be 2. So this 2 square roots of 7 on number 4 is my final answer. And now I'm going to try number 6. Number 6 says I have the square root of 32. You can break 32 up in a bunch of different ways. I'm going to use 8 times 4. 8 breaks down to be 4 times 2. I'm going to circle the 2 because it's a prime number. This 4 breaks down to be 2 times 2. I'm going to circle those. And then this 4 breaks down to be 2 times 2. So now I'm going to replace that square root of 32 with these 5 2's. I need 2 of a number to release it from the radical. So you will notice in number 6, I can actually pull out 2 sets of number. One set of 2's comes out, another set of 2's comes out, and then that 2 is left under the radical because it does not have another 2 to release it. So the question remains, what do we do with these 2's that we released from the radical? So when they were under the radical, these little dots mean that they were being multiplied. So when you pull them out of the radical, they are still going to be multiplied by each other. So 2 times 2 gives me 4, and then I have my square root of 2. Moving on to number 8, I have the negative square root of 96. You may also read that as the opposite of the square root of 96. So we can break 96 down to be 3 times 32. And then we just broke 32 down up here, but we can go ahead and rework it. Again, you could have used any other factors of 32. You could have used 2 times 16. 8 and 4 works. So any of those that multiply to give you 32 will work. Okay. So now I'm going to replace my square root of 96 to have these 5 2's and that 1 3. So I'm going to write my 5 2's and my 3. And then I'm going to circle my pairs that I can pull out of the radical. This 2 comes out as 1. This 2 comes out as 1. And my 2 times 3 stays under the radical. So negative 2 times 2 gives me negative 4. And then that 2 times 3 gives you 6. So remember, this was the opposite of the square root of 96. So if we were just doing the square root of 96 and ignored all of these negative signs, so acted like these did not exist, then that would have been a regular 2 times 2, which would have been a regular 4, square roots of 6. But if we're asking for the opposite of that, then the opposite of positive 4 square roots of 6, sorry about that, is going to be negative 4 square roots of 6. Okay, now let's look at number 10. Number 10 says we have the square root of 150. So we're going to make our prime factorization tree. I'm going to use the factors 15 and 10. And then for 15, I'm going to use 3 and 5. They are both prime numbers, so I'm going to circle them. And then 10 breaks down to be 2 and 5. So I'm going to replace the square root of 150 with 2 times 3 times 5 times 5. Remember, all of these circled prime numbers are what you replace the initial 150 with. So this blank space here means that we need 2 of a number to release it from the radical. So that would be these 2 numbers here. They come out as 1, 5, and I'm left with that 2 times 3, which is the same thing as 5 onto the square root of 6. That's as simplified as it gets. So 5 onto the square root of 6 is my answer. Moving on to number 12, I have the square root of 128. I'm going to use the factors 4 and 32. 4 breaks down to be 2 and 2. 32 breaks down to be 4 and 8. 4 again is 2 and 2. 8 is 2 and 4. And then 4 is 2 and 2. So I have 1, 2, 3, 4, 5, 6, 7 2's. So I'm going to replace my 128 with 7 2's. And I can pull out 2 at a time. So I notice that 3 2's will come out. So 2 times 2 times 2, and that 2 right here is left under the radical because it doesn't have another match. So again, this 2 is that one brought out. Same with here, and then same with here. Remember, since we're multiplying those 2's inside of the radical, that means we're going to multiply those numbers once they come out of the radical. So 2 times 2 gives us 4. 4 times 2 gives us 8. So that gives me 8 onto the square root of 2. Now number 14 says that I have the cubed root of negative 54. Well, we know that the cubed root of a negative number is always going to be negative. So we know our answer will be negative. We can put, in all of your problems I give you, you're always going to have an answer space. So go ahead and put your negative sign in that answer space. So 54 breaks down to be 9 times 6. 9 breaks down to be 3 and 3. 6 breaks down to be 3 and 2. So that gives me the cubed root of 2 times 3 times 3 times 3. And then don't forget you've got that negative in there. Technically, we don't have to worry about it anymore because we already have established that our answer will be negative. So this index right here is no longer blank as it was in the earlier problems. So that 3 means we need 3 of a number to release it from the radical. So I can pull this set of 3's out as just 1 3. Remember, a negative comes out and you're left with the square root of 2. So negative 3 square roots of 2 is my answer. So now look at number 16. I have the cubed root of 250. So 250 breaks down to be 25 and 10. 25 breaks down to be 5 and 5. 10 breaks down to be 5 and 2. Remember, you circle all of those prime numbers. Now I'm going to break that cubed root of 250 apart, and I'm going to replace it with that 2 and those 3 5's we have circled. So the cubed root tells me I need 3 of a number to release it. So I'm going to circle those 3 5's. They come out as just 1 5. And then that 2 stays on the inside of the radical because it does not have enough of those 2's to release it. Now, be sure to include that cubed root symbol. If you do not put that 3, your answer is automatically incorrect. You've got to remember to do that because that completely changes your problem. Now let's move on to number 18, where we have the cubed root of negative 160. Again, when you have the cubed root of a number that is negative, you know your answer will automatically be negative. So we don't have to worry about that anymore. 16 times 10 are my factors I chose. Then we have 4 and 4, and then those 4s break down to be 2s. And then 10 breaks down to be 2 and 5. So I'm going to replace my cubed root of negative 160 to have these 1, 2, 3, 4, 5 2s. And then that 1 5. So that 3 in our index tells us we need 3 of a number to release it from the radical. So we know that negative comes out, a 2 comes out. Remember, those 3 2's come out as just that 1 2. And then I have that 2 times 2 times 5 inside of the radical. So to further simplify, I'm going to multiply those numbers together to get 20. I get that because 2 times 2 is 4, and then 4 times 5 is 20. So my final answer would be negative 2 onto the cubed root of 20. It's very hard to forget that cubed root, guys, so make sure y'all are including it. Number 20 says I have the 4th root of 96. So 96, we've done this earlier, I believe. 3 goes into 96 32 times. 32 breaks down to be 16 and 2. 16 breaks down to be 4 and 4. And then 2 and 2. So I'm going to replace that 4th root of 96 to be 1, 2, 3, 4, 5 2's, and then a 3. So I need 4 of a number to release it from the radical per my index right here. So those 4 2's come out just as 1 2, and I'm left with the 4th root of 2 times 3. So our final answer is going to be 2 onto the 4th root of 6. So now let's move on to number 22. Number 22 says I've got the square root of 45a squared. 45 breaks down to be 9 times 5. 9 breaks down to be 3 times 3. So I'm going to replace 45 with 3 times 3 times 5. And then I can break the a's down to be a times a. So I need 2 of something to release it from the radical because I don't have anything right here, so that means it's an automatic 2 for my index. And then I can pull out 2 a's. So a 3 and an a will come out, and a 5 will say under the radical. So we are finished with number 22. 24 says I have the square root of 54 w to the 4th. 54 breaks down to be 9 times 6. 9 breaks down to be 3 times 3. 6 breaks down to be 3 times 2. Going to circle all of those prime numbers and replace the 54 with those. So I've got 2 times 3, 3, and 3. Then I'm going to write my 4 W's. So I need 2 of a number to release it from the radical. So I can pull out a pair of 3's, pair of W's here, and a pair of W's here. So that gives me 3 W and W, and then I have a 2 and a 3 left on the inside. Now these two W's right here, W times W is W squared. So I'm going to have 3W squared onto the square root of 6. Now when looking at these exponents, these variables with exponents inside of your radical, you are going to notice that there is a shortcut you can take. If you take your index, as in number 22, index was understood to be a 2. So over here, how many times does 2 go into 2? The answer will be 1. So an a to the first was released with no remainder. So no a stayed inside. Over here, it was an understood 2. 2 goes into 4 2 times evenly. So there's no remainder, so no 2 stay under that radical. On number 26, we're going to see something a little bit different. Number 26 says I have the square root of 75 a to the 5th. 75 breaks down to be 25 times 3. And then 25 breaks down to be 5 and 5. So I release my 75 with that 3, 5, and 5. And then I have my 5 A's. So a pair of 5's come out. And then you notice that 2 pairs of A's come out. So I have 5 times A times A. And then that 3A is left under the radical. So to simplify that, A times A is A squared. So I have 5A squared on a square root of 3A. If we were to use the shortcut that we discussed earlier, the index is understood to be a 2. So that 2 goes into 5 2 times evenly. So 2 of those A's come out, and then there was a remainder of 1, so that's why an A to the first stayed under the radical. So 28 says I have 108 p to the 5 q squared, all under the square root. $108 breaks down to be 2 times 54. 54 is 9 times 6. 9 is 3 times 3. 6 is 2 times 3. So I'm going to work this problem without writing out all of my variables like I did up here in number 26. So I'm going to write my numbers still. So I had 2 2's and 3 3's. I'm just going to write my p to the 5th and my q squared. If you still need to write out your p's and q's, that is no problem. You should still get the same exact answer that I do. So I can pull out a pair of 2's. I can pull out a pair of 3's. So I have 2 times 3 on the outside, and that 3 stays on the inside. My index is understood to be a 2. So 2 goes into 5 2 times evenly. So a p squared comes out. But we still had a leftover of p to the first. And then 2 goes into 2 one time. So that's how I have a q to the first come out, and none of them stay on the inside. For clarification, you do not need to write these ones for the q to the first and p to the first. If it is not written, it is just understood to be a 1. So to finish my answer, I will have 2 times 3, which is 6, p squared, q, onto the square root of 3p. Moving on to number 30, I have the cubed root of 16x to the third. 16 breaks down to be 4 times 4, which is 2 times 2 and 2 times 2. So I'm going to rewrite my 16 to be these 4 2's. And then I have my x to the third. So I need 3 of a number to come out of the radical, which is what my index tells me. So 3 2's will pull out. And then that 2 stays under the radical because I only have 1 of those now. Then 3 goes into 3 one time, so an x to the first comes out. And there was no remainder. So my final answer will be 3x onto the cubed root of 2. Now let's look at number 32. Number 32 says I have the cubed root of negative 80a to the 6th. So I know, based on what we have learned so far, that my answer will be negative because I have the cubed root of a negative number. So 80 breaks down to be 8 times 10. 8 is 4 and 2, and then 4 is 2 and 2. And 10 breaks down to be 2 and 5. So I'm going to replace my cubed root of negative 80 with those 4 2's and that 5, which 3 2's come out, and that 2 times 5 stays under the radical. Now we have an a to the 6th still. So 3 goes into 6 2 times evenly. So I'm going to have an a squared released with no a's staying inside because there is no remainder. So my final answer here will be negative 2a squared onto the square root of 10. Number 34 says I have the cubed root of 250 x to the 13. So 250 will break down to be 25 and 10, and then 25 will break down to be 5 and 5, and then my 10 will break down to be 5 and 2. So now I will replace my 250 with those 3 5's and that 2. So I'm going to be able to pull out these 3 5's at once, and that 2 stays under the radical. 3 goes into 13 4 times evenly. So an x to the 4th comes out, and then I'm going to have 1x left over. My final answer is 5x to the 4th onto the cubed root of 2x. Now let's look at number 36. So on number 36, they're asking for the opposite of the cubed root of 250, a to the 4th, b to the 15, and c to the 9. So this problem is really going to challenge whether or not we know what we're doing here. If you would like to pause this video so you can try this problem yourself and then check your answer, feel free to do so. I'll give you a second to find the pause button. Okay, so 250 breaks down to be 25 and 10. 25 breaks down to be 5 and 5. 10 breaks down to be 5 and 2. So I will replace this 250 with that 2 and those 3 5s. And then I have my a to the 4, b to the 15, and c to the 9. Now make sure your radical sign goes over all of that expression. Looks like I can't really see my 9 very well. Let's see if I can fix that. Okay, so now these 3 5s come out as just 1 5, and then that 2 stays under the radical. Now 3 goes into 4 one time, so an a to the 1st comes out, but we have a remainder of 1, so an a to the 1st stays inside of the radical. Then 3 goes into 15 5 times, so that leaves us with a b to the 5th with no b's left under the radical. And then 3 goes into 9 3 times with no remainder, so no c's are left under the radical. So our final answer is going to be the opposite of 5ab to the 5th, c to the 3rd, onto the cubed root of 2a. So the opposite would be the negative of that. On number 38, we have the 4th root of 96, w to the 5, z to the 13. So 96 breaks down to be 3 times 32. 32 breaks down to be 16 and 2. 16 breaks down to be 4 and 4. And then your 4s break down to be 2s. So I'm going to rewrite this problem with my 2s and my 1, 3 replacing the 96. So I have 1, 2, 3, 4, 5 2s, and 1 3. Then I have a w to the 5 and a z to the 13. I need 4 of a number to release it from the radical based on my index. So I'll pull out 4 2s as just 1 2. My 2 times 3 is left under the radical. 4 goes into 5 one time, so a w to the 1st comes out, and then a w to the 1st is left inside because there was a remainder of 1. 4 goes into 13 3 times. Oops. And there is a 1 left over, so a z to the 1st is left under the radical. So our answer is going to be 2w z to the 3rd onto the 4th root of 6, because 2 times 3 is 6, WZ. Now on to number 40. Number 40 says I have the fifth root of 64 W to the 10. So 64 breaks down to be 8 and 8. 8's break down to be 4 and 2. And my 4's break down to be 2 and 2. So I have 6 2's here. So I'm going to replace my 64 with those 6 2's. And then I have my W to the 10. So I need 5 of a number to release it from the radical per my index. So these 5 2's come out as just 1 2. And then I have a 2 left under the radical. Then 5 goes into 10 2 times, so a W squared comes out of the radical. There's no remainder, so no W's stay under the radical. And that is my final answer for number 40. You will notice on numbers 42 through 46 even we are about to do, we have radicals that are fractions, so radical expressions that are fractions. We are going to learn what we need to do to simplify these. The golden rule you need to remember is that you cannot have a radical in the denominator. So on number 42, I have the square root of a to the 6th over 49. So the first thing we can do is break up this fraction to be the square root of a to the 6th over the square root of 49. The square root of a to the 6th, we can either write a out 6 times, like we did before, or we could say my index is 2, and 2 goes into 6 3 times. Then the square root of 49 is 7. We are now finished. The whole goal is to get that radical out of that denominator, and so right now we're just simplifying. Number 44, I have the square root of 7 over 25x squared. So remember, we break this down to be the square root of 7 over the square root of 25x squared. There is no square root of 7. 7 is a prime number, so it does not break down. So we're just going to leave that as the square root of 7. But 25 breaks down to be a 5, because 5 times 5 is 25. And then x squared, the square root of that would just be x. With the radicals out of the denominator, so we're good to go. We have simplified it as far as it can go. Now we're going to do the final problem of this section, which is number 46. On number 46, I have the cubed root of 4x squared over 27. So I'm going to break this up to be the cubed root of 4x squared over the cubed root of 27. So 4 breaks down to be 2 times 2, but I need 3 of a number to release it from the radical. So since there would only be 2 2's in here, I know that my numerator will not simplify. Same reason why we can't bring any x's out, because by that index I need 3 of something to pull it out of the radical. Then the cubed root of 27, meaning what number times itself 3 times gives me 27, that answer would be 3. Again, please do not forget to include that cubed root, that 3 for your index, if it is written in your original problem. In the next lesson, you are going to learn about rationalizing the denominator. That lesson I decided to group together in one video. It's a little more difficult to understand. So in order to complete your homework on this section, please look at the next video titled Rationalizing the Denominator. I wish you the best of luck.